Okay, we have a committee of 18 people. Pay attention. 8 boys, 10 girls. Want to form a subcommittee of 5. So no matter what group I'm going to make here, I'm going to have 5 in each group, correct? It says determine the probability. So that means I'm going to need a denominator, correct? Everything else before probability affects the top and the bottom. After probability only affects top. Probability they have at most 2 girls. At most 2 girls means 2 girls or less. So we can have 2 girls or 1 girl or 0 girls. And then I need to supplement because each of these cases has to have how many people? 5. So 2 girls and 3 boys, or 1 girl and 4 boys, or 0 girls and 5 boys. Now we have to decide, is it a C or a P? Do they have jobs in this subcommittee? No. Any occupations, anything to do, anything different? No, so it's going to be a C. So we're going to do 10C2 times 8C3 plus 10C1 times 8C4 plus 10C0, which I don't have to put, but I'm going to, times 8C5. And then because it's probability, I have to have denominator, which is no restriction. So how many do I have to choose from? 18, and I choose 5. Did anyone put that in?
Why did you put 18 and 5 on the bottom?
Probability. You need a denominator. Has to be over a total in order to get a probability. If you put the top in, what do you get? Anyone put the top in separately? 3,000. Okay. And then the bottom, we get 8,568 possible subcommittees, right? And I get 0.38. Okay, we have number 6, a 4-digit code which cannot be repeated is selected. So that's all stated below or before the word probability. So it affects the top and the bottom, correct? So it says 4-digit code cannot be repeated. That affects the top and the bottom. After the word probability, it only affects the top. Probability, the code contains only odd digits. So I have a 4-letter code, or 4-digit code, sorry, and it can only contain odd digits, but they still can't be repeated, right? Both top and bottom can't be repeated because it happened before. So I'd have 1, 3, 5, 7, 9. So I'd have 5. Then I would have to hold 1. So then I would have 4, then 3, then 2. And codes, does order matter in codes? Yes, if you're not, you could put the code in and out of order and it would still get you into whatever you were trying to get into, correct? Which isn't possible. So that's why we do the blanks, because we're ordering the code. We're seeing the code visually ordered. And then on the bottom, the only restriction is we can't repeat, correct? So we have 0 to 9, which is 10. Then I hold one of them, so I have 9, then 8, then. And why can I start with a 0? It said digit. It says 4-digit code. Can code start with zeros? Yeah, code could be all zeros, right? It's only if it's a 4-digit number that we can't start with a 0. So then I go 5 times 4 times 3 times 2, and I get 120 over 10 times 9 times 8 times 7, which is 5,040. Now remember, we can also use p's. If we started a number and go down by 1 each time, I could go 5p. How many did I go down by? 4. And then this one could be 10p 4. If I started a number and I go down by 1, I can use the p, right? So that's how I know it's permutation too. So 120 divided by 5,040. And I get 0.02. If I say probability to the nearest hundredth. If I said to the nearest tenth of a percent, I would take that, times it by 100, and I would get 2.4%. So that's if I said nearest tenth of a percent. Number 7 talks about odds. If I give you a probability, you can get odds from it. If I give you odds, you can get a probability, right? You should be able to do them and vice versa. That's fair game for the test. So the probability it will snow is 0.75, which is 3 out of 4. And how can I do that? I can go 0.75 math enter, and it turns into a fraction for me, right? It's a great thing with those calculators. Or I can go 0.75 times by 100. I get 75 out of 100, right? Reduce that to 3/4. Either way. What I like to do if there's odds questions is I'll give probability of snow, and then I'll also list the probability of not snow, which is 1/4. And the reason why I do that is because then I have all the numbers I possibly could need. 4 would be the total of odds, right? 3 would be if it's snow, 1 would be if it's not snow. I have every number I could possibly need for odds, correct? So here it says determine the odds against, means whatever comes after comes, odds against? Second. Odds against snow. So snow comes second, not snow comes first. How many not snows are there?
1.
How many snows are there? What does this add up to? Which is the total, the denominator. So we know we're good. This one says odds in favor, whatever comes after favor comes first. Odds in favor of not snowing. So not snow to snow. Wait, these are the exact same question, written differently. 1 to 3. Here, determine the probability it will not snow. Wow, look at me, I already found that. Probability of not snow is going to be 1/4. Because complements should add, probability should add up to 1. Okay? All right. I'm going to get you guys, you won't have your textbooks probably on you, so you can take pictures of mine. But I'm going to give you some. Number 2 says draw a Venn diagram. I don't need you to draw a Venn diagram. The question for number 2 is, Pearl is about to draw a card at random from the standard deck of 52 cards. If she draws a face card or a spade, she will win. Draw a Venn diagram. I don't need you to draw a Venn diagram. I just want you to answer B and C. Okay, so this one gives us probability of Brenda getting a hit is the baseball game is 0.345. Probability of Brenda or Deborah getting a hit is 0.617. The probability of both Brenda and Deborah getting a hit is 0.224. You need to grab a pen. So, we can draw ourselves a Venn diagram because it's a probability Venn diagram this time. So this would be Brenda. This would be Deborah. You can start in the middle. Both of them getting hit at 0.224. Can I do the or next? If I do the or next, it's the whole snowman. There's 2 pieces missing, right? So I can't do that next. But I can do Brenda getting a hit at 0.345. So there's already 0.224. If I take 0.345 and subtract 0.224, what do I get? Now can I do the OR? Yeah. So the OR is 0.617, so I can go 0.121, 0.224, subtract that from 0.617, and I get 0 decimal. Yeah. How many would be on the outside? How'd you get that? Yeah. So the whole probability then should add to 1. So you're correct. You did 1 minus the 3. Or you could do 1 minus the 0.617. Anyways. In terms of probability that Deborah is getting a hit, so what do we have to add to get probability of Deborah getting a hit? What two numbers do we add together? 0.224 plus 0.272, and I get 0.496. Did you get that? Because you have to add up the Deborah one. It doesn't say Deborah only, right? If it said the probability of Deborah only getting a hit, it would be 0.272, correct? But you have to add the two up. So you have to spot these as a Venn diagram probability, so they would add to 1. We agree? Another question they could ask on here is what's the probability that Brenda or Deborah don't get a hit, which would be 0.383, right? You could ask the outside number as well. All right. Next page. I want you guys to try these ones. You're first going to have to decide when there's the or in between. You're going to have to decide if they're what? Mutually exclusive, which means I add nothing off because there's no, I subtract nothing off because there's no overlap. Or not mutually exclusive and I subtract the overlap off because I'm counting it twice. Correct? So for every single one of these, it has a spinners being spun 1 to 10. Each number is equally likely to be spun. What's the probability of an even or a factor of 3? So I always list my options. Even would be 2, 4, 6, 8, 10. I always list them below. I know it takes a bit more time, but it's a lot easier to determine if something is overlap or not, right? Factors of 3. What multiplies to give me 3? 1 and 3. Then I look and I say, is there overlap? Anything overlapping between 2, 4, 6, 8, 10, and 1 and 3? Nope. So this is mutually exclusive. Remember? And when it's mutually exclusive, then I can just add the two probabilities and I'm done. Right? So an even number would be 5 out of 10. And some people want to reduce. Don't reduce. If you reduce, you're going to have different denominators. They won't be common. It's harder to put them together. Right? So 5 out of 10 plus factor of 3 is 2 out of 10. So I get it equals to 7 out of 10, or 0.7. Right? I want you to do B and C. Yeah, B and C. Okay, let's look at B. Odd numbers. So odd numbers would be 1, 3, 5, 7, 9. Multiples of 3 start at 3 and go up by 3, so 3, 6, and 9. Are there any overlap? Yes. So we say not mutually. And how do we check for mutually exclusive or not? The word or between them. Or screams. Check for mutually exclusive or not, okay? So not mutually exclusive. And so we do the probability of odd, which is 5 out of 10, plus the probability of multiples of 3, which is 3 out of 10. And then we have to subtract off the numbers that double up, which are 3 and 9, correct? There's 2 of them. So we counted them in both of these probabilities, so we take it off once. So we get 5 plus 3 is 8, plus minus 2 is 6 out of 9. 9, 10. Which is 3 out of 5, which is 0 decimal. Then we have a number less than 8. So that's 1, 2, 3, 4, 5, 6, 7. I stop at 7 because it says less than, not less than or equal to, right? And a divisor of 15. A divisor of 15 is something that can go into 15 that doesn't get you a decimal. So 1 can go into 15, 3, 5. That's about it. If I do any other numbers, if I divide them in, I'll get a decimal, right? So they're not a divisor. Okay. Are there any overlaps? Actually, all of them are overlapped, aren't they? So this is not mutually exclusive. So we're going to get 7 out of 10 for less than 8, plus 3 out of 10 for divisors of 15, minus 3 out of 10 for the overlap. So it's actually 7 out of 10, which is 0.7. And the reason why you subtract is they're already counted in the first one, right? So if we count them again in the second, we're counting them twice. Does that make sense? So we take it off once to get rid of the double up. But if there's no double up, we don't have to take it off. You try out example 3. Looks like a probability Venn to me. So in a particular class, the probability that a student has a home video game system is 0.2. So that could have other ones too, right? It doesn't say only. In the same class, probability that a student will have a home video game system and a TV in their bedroom is 0.46. So that's an and. Assuming that having a home video game system and having a TV in their bedroom are independent, so they could have both. Doesn't matter, you don't have to have one or the other. Determine the probability to the nearest hundredth that a student in the class has a TV. Okay, so let's go through what we have. Okay, the in-between has what? 0.46. Gaming and TV. The home gaming system is 0.62. So how many are just in gaming? The part that's missing is they have to say, technically, that each student has either a gaming system or a TV. So how could I figure out the rest? Yeah, 1 minus 0.16 minus 0.46, and what do we get? So they had to specify which was missing, that they had to have one or the other. If not, we weren't given enough information. So here it says, to the nearest hundredth that a student in class has a TV. So what do we have to do to get a TV? Probability of a TV. What do we have to add up? 0.46, because they still have a TV, right? Plus 0.38. And we'll get 4, 8, 0. So it's 0.84. Then we flip over. So this one here is the probability that Eric will play golf this weekend is 0.5. The probability you play tennis is 0.35. The probability he'll do neither is 0.25. So I gave you each and neither and a probability Venn, right? So we can find out the answer to the both, correct? By adding them up and then subtracting what? 1. So if we go 0.5 plus 0.3 plus 0.25, what do we get? 1.05? If I subtract 1 from that, the overlap is 0.05, right? So I go to draw my Venn diagram. Probability Venn, so it has probabilities. I have golf and I have tennis. Now, he plays golf is 0.5, so that means the whole circle should have 0.5. It already has 0.05, so it's 0.45 golf only. And then tennis is 0.3, but it already has 0.5, so this is 0.25. And then on the outside, I have 0.25. Now, what should all of these add up to in a probability Venn? 1. And if they don't, you're wrong. Correct? The probability Venn diagram, when it's decimal, should add up to 1. If the probability Venn diagram is percents, it should add up to 100. Like if they give it to you in percents instead of decimals. So here it says the probability that he will do at least one of the activities. At least one of the activities is golf, tennis, or both golf and tennis, right? Because he could do both. It's at least one. So it's everything but the neither. So what would it be? C, 0.75. And then 4b says the probability to the nearest hundredth that he will play tennis and golf is 0.05. Remember, you have to start with a 0 because the decimals are only in these two boxes on the test. That's it for today.